and I'll hide this zoom control on my screen here as well, just to give it a little bit more space, and also minimize that in the corner as well. As I say, I'm keeping track of this on my other screen, so I'll try and keep an eye out for any uh, issues or anything that come up in the chat as well. So the basic breakdown of this is that we're going to explore how rucio can be used and basically the recommended workflow now in terms of using this to find files from X simulations and then download or stream them in analyses, things like that. So if you can follow along, that's great. Give you an opportunity to basically try some of these commands, try playing around rucio, giving it a go and seeing what it can do, and getting a kind of feel for how to use it as well. Using it does require ESC shell. So if you have that installed, that's great. I'm just going to exit this so I can show kind of joining it. I have some directory where I have ESC shell here sitting at the bottom. I can run that, get in the container basically and start running things as well. So we can try commands from there as well. So if you have that, that's great. If not, you won't be able to follow along as much. But nonetheless, hopefully you'll find it useful as we go along. And you can try these things out when you do have access to that as well. So just by means of introduction, I do want to briefly talk about simulation campaigns within Epic, ESE simulations, what these are, what they're used for, and just a little bit of a sort of bit of background for this in terms of why you might want to try and find these files to begin with as well. And also just because this information, to be honest, is spread throughout several bits and pieces of the documentation. So really just to have a centralized place for this as well. So this part, not so much to do, just a little bit of background, a bit of explanation here as well. Some links for further reading points as well. So basically, with where we are with Epic and the EIC, we're in a quite intense period of running simulations for lots of different purposes. For physics analyses, just to demonstrate what Epic and the EIC will be able to do, what kind of physics outcomes we can expect, and what kind of impact we can expect from this new machine. But as well as that, there's a lot of work going on in terms of detector optimization, as basically we're getting to a point where detectors are at 60 to 100% design readiness and are going to be under construction very soon. So lots of different things are simulated, and that simulation takes a lot of computing time. And the production working group of Epic and the ESE software working group runs a lot of monthly campaigns basically to process simulations for a lot of these purposes. So for detector studies, for physics studies, and so on. So these run on a monthly basis. Sometimes a month is skipped for a particular reason, or there might be multiple campaigns within a month, as we'll touch on in a second. But typically these are run monthly, and you can find information about the different campaigns on their page there as well, including the files that are produced in different campaigns too. You can also take a look at a list of kind of current requests from detector subsystem coordinators and physics analysis coordinators as well at this link here. So this basically just shows you what kind of things are in the simulation campaigns currently. And also if you want to request something new, as we'll touch on in a second, that's something that you should then eventually see in that list as well. Just gives you a feel for what is being produced, what sort of requests are going in, and what you can try and look out for if you just want to maybe take a look at some data and see what's going on here as well. These campaigns, as I say, that they're done on this monthly kind of cadence generally, with some exceptions, and they generally follow this sort of standardized format. So it's something like year, month, and then version, with 0 being the kind of first version. And this corresponds to a specific software release as well. So typically there will be a monthly software release and a monthly container release. So you could say, okay, I want to look at the software as it was at a certain point, and that's kind of a snapshot of that as well. So with it being like that, year, 26 basically is telling you that's from the 2026 campaign at some point, and then the month characters are just telling you which month it was in. So 26 would be this year, 02 would be February, and then the final one, the version, whether this is 0, 1, 2, so on, basically just telling you what version of the container and what version of the software that is used there. There are some months where maybe there is only one version, it might just be version 0. There are others where maybe something has been noticed during production that has necessitated a patch or a change, and that's why there might be a different version of the container there as well. It might only affect certain types of simulations in some cases. So, for example, electron proton might have been unaffected, but electron ion simulations might have been affected by some particular change that needs a patch or an update there as well. So, as I say, these are linked to specific software releases. They all follow that same format. So, if you're looking at something like 26030, that's a March 2026 container version as an example. One thing to keep an eye out for and keep in mind, in particular, if you're looking at other tutorials and they reference, get some file from a campaign and it's something like the 2024 campaign or something like that, you might not be able to directly access that using the methods we have in this tutorial. So you might want to try running something a bit more recent. Typically, stuff more than 6 months old won't be directly accessible using some of the stuff we're going to use here. There are exceptions to that. Some software releases are particularly notable. One example is the October campaign last year, which was kind of set as a fixed point for pre-TDR, pre-technical design review report studies. So those are kind of there and are accessible a little bit more readily because that was chosen as a kind of benchmark campaign to run for the pre-TDR document. There are exceptions to that, but generally the rule is that once they get to kind of 6 months or older, you have to access them using slightly different methods. So you should try and access slightly newer files where possible. So we're going to explore in this tutorial basically situations where we can access ones within 6 months effectively. So trying to find the most kind of recent generally. Most of the time, that's what you would want, unless you're trying to kind of track back and see what has changed or maybe where something has gone wrong as an example. Some change down the line has impacted your study and you want to find that out. Generally speaking, you probably want to work for the latest files that are there. One thing to add here as well, just in terms of if you want to submit a new simulation request, there is a procedure for that. I won't run through it here, but just keep in mind that that's something you want to do. Say you have a new physics channel you really want to study, you really want to go and look at production of some meson off electron proton collisions, something like that, I don't know. And you have your event generator that you want to go and get some events for and plug it in. The procedure's there. There are certain rules in terms of making sure that's reproducible, kind of fitting in with FAIR guidelines, basically. So making sure that the software is findable, accessible, reusable, and so on. And that's basically just in terms of documenting what version you ran, what commands you ran. So, for example, the generator, maybe what specific input card you've used for that generator or something like that as well. So there are guidelines for that. Which need to be followed, but generally it's fairly straightforward and will help kind of going forward. Say if you want to maybe run some new files in the future, you can go and look back at what you did previously and see what's changed and what you want to update. In terms of once things run, so say you've submitted a request and you get some output from it, it's in the simulation campaign, great. Generally, these files are organized, as we'll see in the next little bit as well, into a few distinct categories. So within a simulation campaign, there's really three broad classes of file that are produced. EvGen, so basically this might be some input HepMC3 data set, so something that's directly there from some physics event generator or something like that. There's then these full files, which are basically the full Geant4 output, which are usually only saved for a small fraction of runs or in special cases, which might be kind of detector level information, very granular simulation output, basically. And if you ran a simulation yourself, so if you're kind of following through in the analysis tutorial as an example, there's a part about this full chain analysis. This would basically be the output of something like NPSim. So you take your events, you fire them into the simulation. This is basically your Geant4 sort of level output and would give you kind of hit level information, if you like, about stuff there as well. What's more generally useful and used certainly is this final one, RICO. So this is basically the reconstruction level output. So this is once that is simulated, you pass it through EXE Recon, and it outputs information such as particle clusters, things like that. That's the sort of level of information that's there as well. Most users, and I think most use cases, which we'll explore a little bit later on, are really there to interact with these RICO level files as well. The output of the full simulation and kind of reconstruction chain is in these files. We will look at the others, that there might be specific cases where you want Geant4 level information, generally more if you're looking at something like detector development, you might want to go and look at what's happening at the geomet level. Maybe some clusters don't make sense in your detector that you're working on or something like that, which is the output of the reconstruction. Is it some problem with the actual simulation, or is it a problem with the reconstruction? Sort of question you might want to try and answer by looking at both of those. So, uh, where we are today, though, and what we want to do is really well, great. All of these files are there. You can go and look and see what's there and what's available. But how do we actually access that information? How do we use it? Well, the answer to that is to browse these files and find the files we want. We can use rucio. So this is an open source scientific data management system, which is utilized in other large physics experiments such as Atlas. And with the EAC and with EPIC, it's something that we've moved to simply because we're now at a stage where when we're simulating things, so as part of these regular simulation campaigns, a lot is being processed month to month and storing it at one particular site. Previously, all the information was sitting on JLab servers. Now it's actually distributed across multiple sites. And Rucio is actually something which kind of lets us keep track of that, know where things are stored, and access them appropriately. So just as a kind of flag here as well, if you look at all the tutorials and if you look at even, for example, the analysis tutorial, they'll talk maybe about extrude and might even be something you're still using to access files. You might see instructions or some reference on using this to browse and access files. These will still work, and actually we'll be using extrude for a particular reason in a little bit. There are issues with it which we'll touch on, but in terms of finding files, rucio is really the preferred method now as well. The recommended workflow really is that you can find the file location of rucio, find which server it's on, and then stream or download it as appropriate with extrude. We can also download rucio, as we'll see in a second. There's maybe some quirks to that which we might want to avoid, some positives and negatives of it, but this is generally the workflow we'd recommend. Find where things are, rucio, use the tools, use metadata tags to find things easily, and then access them using extrude. So, does touch briefly on this as well in terms of, just said that this isn't just a change to make everyone learn something new and just a change to something new for the sake of it. It's really kind of a consequence of the expansion of the volume of data that we have available now as well. Before this year, everything was just being stored on JLab servers, but now we have Brookhaven servers available for data storage, and also there'll be other systems coming online as well from different sites. And Rucio just really lets us kind of keep track of that and deal with that in a very straightforward way. It's not really something that generally you need to worry about. You just say, you find the files you want, get the location from Rucio, and it already kind of tells you which site they're sitting on, things like that as well. One other thing to mention is you might still find reference, particularly if you may be searching something on Mattermost or something like that. It's some very old post or suggestion from someone. They might reference this S3 server. This is now something that's just not used at all. So if you do find any references or instructions on using that, particularly in tutorial material, please just let us know or raise an issue on the GitHub page for the tutorial, and we'll try and get that removed. Not something that's used anymore, and won't be used going forward as well. So that's the kind of just sitting and listening side of things done. We'll actually start to see how we can use this tool in the next section there as well. So before I continue, any quick questions on any of that? Anything unclear? Any links broken? Things like that? Because if not, I'll just move on and we'll start to look at how we can actually use Rucio and some of the great things we can do with it. Give people a minute or two to type. I'm not there. Yeah, Sasha, go ahead.
Why don't we use extrude servers? Why do we need rucio?
Well, so sorry. So why did we use extrude?
No, why don't we use only extrude? Because it can also locate files, right?
It can, but you need to kind of keep track of which server you're on. And month to month, that's not necessarily going to be the same. So, for example, one month your files might be stored on JLab servers. Great, I've set everything up using extrude. I'm going to go and run my script. All of a sudden, things are moved and you can't access them on that server. Bit of a problem. I mean, you can get around it. You can, try and tweak things, but as we kind of add more and more sites, it's going to become more and more of a problem. You're going to have to add basically different use cases. Okay, if it's not here, try here, things like that. You
And
can just get past all of that by using Rucio, which will tell you, they're here for this particular campaign.
And follow-up question. So the rucio lets me access without any permissions on JLab, but BNL is protected by permissions. So what do I do? Will you tell it in the future?
Anything that is findable, we'll see one of the commands we can use rucio. We can specifically say, is it actually open access and can we access it? So even files that are stored on Brookhaven servers, you can access from use rucio as well and xroot. So there are quirks to that, and actually that's one of the reasons where searching using xroot is a bit more of a pain because you can't kind of hunt through if they are on Brookhaven servers as an example, you can't hunt through quite as easily. But if you know the exact location, you can just grab it, as we'll see in a little bit as well. Rucio doesn't really care; it just finds it. Here it is, and oh, it's a Brookhaven server.
Thanks, because MCP tools are now available for AI. So thank you.
All right, so we'll move on to the next section, which is actually starting to use Rucio and starting to run this. So if you haven't been to one of these tutorials before, the way this generally runs is if you are looking at the tutorial on the pages I am on the right here, there are sort of code snippets and bits and pieces. Really the encouragement here is, if you want to try them, just copy them, stick them in your terminal and try running them. So at the minute I'm sitting with an EIC shell, and as you can see, I could just run this command to see if it's there and see what happens. So I'm going to go ahead and do that. I'm just going to say, well, run rucio, tell me who I am, and we'll find hopefully that we basically have some active account that's tied to basically the EIC shell. When you run it, you will have some account that has access to these files and can run these things as well. We can also, of course, do fairly familiar things using Linux. We could say, okay, well, what sort of things can I give this and run -h, see what's available and what kind of arguments I can give it. And we can see the kind of things that Rucio is maybe expecting us to plug in here, which we'll talk about in a second. So, we could specify how we access things. A lot of this we don't necessarily need to play with. It's already pre-configured there. And we can see, okay, we can look at servers, so on. Don't need to worry about this. But we can start to do things like here. Which we'll see in a second, start to find information and get some bits and pieces of what's there as well. So we'll see this in a second, and we'll be talking about these things quite a bit as well, data identifiers, DIDs, because this is basically what Rucio kind of works with there as well. So if you have a EIC shell running, encourage you to try this. Hopefully you'll get very similar output to this, so long as everything's sort of set up and running okay. It's exactly what you should see. And you can basically then try some of these commands a little bit later on as well. So I'm going to clear that before I continue, and then I'll basically discuss a little bit how Rucio is dealing with things and what kind of the basic elements of this are. So in terms of, I'm going to realize this is maybe a little bit small, but I hope people can see it on their own screens as well. Typically, when you're analyzing data, you want to access, something contained within a specific file. You say you have, myfile.root, something like that, containing some information about some events you've simulated. Generally, you're probably going to have multiple files, and you would kind of group them together maybe into some data set. Maybe you're running the EIC, let's say it's some particular BeamNG combination. I've run my favorite process for 9 on 130 GeV events or something like that. And we could say, okay, that data set is the 9 on 130 for this particular channel. You might have a different one. So you might say, actually, that's one data set, and another data set is some container is 9 on 275 or something like that. And you could group those data sets together into some container as well. All three of those things, whether it's an individual file, whether it's a group of files in a data set, or whether it's some group of data sets in a container, all of them are data in some sense, right? So Rucio, rather than talking about these in specific terms like that, really just refers to them as data identifiers. And that's this basic kind of unit that it uses. It talks about DIDs. So one of the things we'll see when we start to look at information is, well, what is that DID? Is it a file? Is it a data set? Or is it some container of data sets? And that's kind of the kind of hierarchy of those things that you would see there as well. It doesn't really care, it, keeps track of that in terms of, you want a DID for something. It could point to a single file, it could point to a data set, or it could point to a container. Just kind of keep that in mind as you're working through things as well. And we'll take a look at what these look like in this little section here as well. Generally, in rucio, all of these data identifiers follow some naming scheme, which is composed of two different things. One is a scope, and the other is a name. Formatted basically as this. So it would be scope, colon, name. In our case, it's nice and straightforward. For Epic, the scope is always the same. So it's just Epic, colon, then whatever the thing is, the name of our data identifier. That name part of this contains information about the data set that we're looking at, or the file that we're looking at, or the container that we're looking at, if you like, as well. And it contains information in there that we've sort of already introduced in terms of software release, as an example, um, things like the Electron 9 beam engines and things like that as well. And if we look at it, just an example of a DID in Rucio, this one actually corresponds to a data set, as we'll see in a minute. It might look something a little bit like this. And as you can see here, it kind of contains between these kind of pairs of slashes information which tells us everything kind of about this data set, really. We've introduced some of these. This little chunk at the beginning here is really just telling us that, okay, this is from the February 2026 campaign, some reconstructed data, and there's some other bits and pieces of information in here as well. So we can kind of take a look through this and break it down. And we'll then talk maybe about what's slightly misleading about this in a second as well. So as I say, this first little chunk, the RECO part there, is just telling us that it's reconstructed output. That then 26020, that's a software release. This next bit, Epic Create a Lake, this is basically just telling us the detector configuration that was used in the simulation. Generally, the naming convention for detector layouts and configurations for Epic is, Epic underscore and then some US national park. In this case, C is alphabetically the third one. They've picked Crater Lake as the one there. I don't know my US national park, so I don't know what other C-based examples would be there. The next part is telling us this is exclusive. So in this particular case, this is actually telling us that this is a data identifier for a data set of exclusive physics events at the EIC. Beyond here, things get a little bit more specific and maybe rely upon some knowledge of processes that you look at the EIC. And this one is telling us that it's, so the next part of that is DEMP. This is telling us the specific process in this case. So exclusive physics, we have lots of specific processes that get analyzed. In this case, it's deeply exclusive meson production. Apologies while I just mute another tab here. Sorry, bear with me. Apologies for this. This one's going to get edited out of the recording. All right, back to there as well. Okay. So that's just telling us the specific process. Beyond that, this DempGen 124, 1.2.4, that's telling us the specific event generator. And then we get into things which may be a bit more general, just telling us 10 on 130, this standard way in which we talk about beam energies at the EIC, electron energy on ion energy. In this case, it's protons. So it's 10 GeV electrons and 100 GeV ions. So 130 GeV ions. And then finally, Q squared 10 to 20, just telling us the Q squared range of these events that have been generated. The final bit, again, specific to this reaction, pi plus, just telling us that it's a set pion plus events being generated from this DEMP channel. So, breaking it down like that, we can begin to understand what is this DID. A few things maybe though that are a bit confusing. If we look at that, this looks kind of like a file path in Unix, right? I mean, it looks like some directory where it's Rico 2602, etc., and it's divided by slashes, where each slash is some folder or something like that, and we eventually get down to some files at the very end of this as well. Where this is maybe slightly confusing is that for Rucio, The DIDs, whilst they look like file paths, are actually flat objects. There is no hierarchy in this as well, which if we start to explore these DIDs can maybe lead us down the wrong path if we're not careful and don't keep that in mind. So do keep that in mind, and as we kind of play around with this, we'll see why that can trip us up. We can work around this as we'll see. But certainly if you're used to doing, maybe I'm trying to find things in my directory here and I say, what's in here? Great, I've got this folder. What's in pick an else tutorial as an example. What's in there? Great, there's some things in there as well. Not the case with rucio, and if we were trying to say, well, what's in this DID? What's under Rico? We're just going to get everything fitting that. It's not going to be a case, okay, it's in that directory now, and it's only going to give us the next level. It's going to give us literally everything that then follows from that as a DID. But there are ways around that, as we'll see. And the example I should stress as well that we've looked at, this was quite specific. Other names and other DIDs won't necessarily contain all the same information. But as a bare minimum, that they're very likely to tell us something about the physics process simulated or the detector process or detector being investigated, things like that. Tell us something about beam conditions and the software release as well. This is all reflected in the metadata tags that we'll see a little bit later on. But generally, most of this will be there. There are some specific elements that might not be, depending on a particular process. Okay, so in terms of using this, how can we actually try and find some DIDs using rucio? Well, we can use this command here. We could use rucio DID list and then give it a scope and a name. So we could go ahead and plug that in. As I say, it's our scope is always just epic. So we could put there, and then if I plugged in the full one above, we'd get the information about it. But I could also use wildcards as well, as we'll see in a second. Could stick something in, run it, and see what happens. We'll do that in just a second. Before that, I'm just going to see, well, okay, what can I do with this command? So what can I do with DID list? Great, some extra options I can give it there as well. So I could give it the options, give it the pattern I'm searching, and see what we can get there as well. One of the things that you notice here is that we can apply these filters. So logically combined filtering expressions. We'll come back to this. Basically, this is something that's going to let us use our metadata tags where we can say we want a certain value to be equal to this. And we can plug in logical expressions there as well. So we might want to find one of the tags, as we'll see, is, for example, electron beam energy. We could say return simulation files with beam energies above 5. And you could make some little logical expression to do that, for example. There's also this short option, which we'll see in a second as well. Quite useful if we literally just want a list and don't want information about what the DID is. But we can try this. We can try and see what happens if we plug this in. And I'm going to use a wildcard. So I'm going to run this command, rucio did list, and epic Rico, and then I'm just going to add /star. So as I said, they look like a file path. And if we were running this and it was actually a set of kind of nested directories, we might expect this just to tell us what is in that level, what's in Rico. Maybe we'll see from our file name above. You see the second thing there is the list of container versions. We might just expect it to tell us, okay, what container options are available to us. But if I run this, there'll be a bit of a delay as it searches these. And what we're going to see is, unfortunately, that actually we get this truly enormous list of DIDs. So, I mean, scrolling up here, keep on scrolling, we see there's this huge, huge list of things. And it's breaking down into, as I say, it's not just giving us which container versions are available, it's giving us literally every DID beyond that to the data set level. As we can see, it's returning a bunch of data sets and telling us basically there's stuff in the February campaign, stuff in January, whole host of stuff. This is actually going back as far as January last year, not this year. So it's kind of all in there, and there's this huge list of information up here as well. So, okay, so far, maybe not that useful. Great, we can return a list of stuff there. But we can maybe work backward from this a little bit. We can try and basically skim things down a bit, and we already kind of know what one of these looks like. So rather than the command we just ran, I'm going to say actually let's kind of try and keep this to a sort of more limited set. Let's just see what's available um, with that DID we had before, but kind of reducing it down a little bit, just adding basically that wildcard on the very last piece of this as well. And when I do that, again, give it a second to run. A little bit more manageable. We now see actually that we just have a few different data sets we can look at here as well. So we get actually 6 data sets in this case returned, where in this case, the different data sets we get correspond to some different beam energies. We see 10 on 250, 10 on 130, and then there's a couple of different Q squared range combinations there as well. It's much more manageable. And what we see is basically just a list of things there as well. We could as well add that short command here to the front and then just see just a list of that, which I'll just quickly do. So this time it's just going to tell us, just the DIDs themselves. So we get those 6 DIDs and it doesn't have this information at the end telling us it's a data set. If you already know it's going to be a data set or a list of files, maybe you just need to run the short version there. But if you're just trying to search, well, what data sets are available, you might want to include that just to check what the DID actually is. We could, though, improve things a bit. We've done it just as a wildcard right at the end. If we already knew what sort of stuff we want to look for, we could try and improve this a little bit by making a bit better use of the wildcards there as well. So say we don't know where they are, what version of the generator we run there in this case. We just know, I'm going to mix this up a little bit, what's there available in the March campaign for this file. We can break that up a little bit and say, okay, I want something that's as reconstructed in there, it's in the Rico directory or Rico area basically. Want something from the March campaign and want these DEMP events in some way. What's available there? I could try and do that by just making a little bit better use of these wildcards and do that. So I can go ahead and do that. Run that again. Again, I haven't run short here, so it's going to tell us basically what they are as well. And what I get is this. So I get, actually in this case, some files run from the March campaign, the first version, some from the 26031 version, but again, a list of data sets matching this. You could change that instead of DEMP, you could put, say you want to run neutral current DIS, you could plug that in as a wildcard there as well, and it would return ones that are available there as well. And that's one way in which you could find files quite easily using rucio. Another way, of course, is using these metadata tags, which we'll see in a second, but that's one way in which we could hunt through these things very quickly. One other thing we can do, though, is that, these things are data sets, which is useful. We know there's some data set of files there for this. Generally, though, you don't want to just say, okay, great, I want the location of some data set or want to know what data sets are available. Typically, in terms of analyzing this, you want the files that are in there to do something with them. Whether that's to copy one of them locally to test, whether that's to process all of them, something like that. So what we can do to get that is to use this slightly different command here, where we can say content list and then give it the location of some DID. In this case, I'm going to plug in one of these DIDs from before and just see what's contained within there. So I'm going to run that and I'm going to say, okay, give me the list of these files here as well. So this time, again, we have a large number of things here. Keep scrolling up. You can imagine this is 0476, is this number changing at the end. So we've got hundreds of files contained within this data set. And as we can see, they are all files. So at this point, this would be something which we could, if we get the location of, which we'll see in a sec, you can say, great, I'll grab that file and do something with it. We could also use short in there as well. So rock content list, I'm just going to add short. And rather than it telling us that they're files, great, it's just going to give us the actual kind of path for each of those as well. So that's very useful, but possibly most useful is because, as I mentioned, this doesn't actually tell us anything about where this is stored. What might be nicer is to say, well, what files are in that data set and where are they stored, or where is one particular file in that data set stored. So to do that, I'm going to use this command here, which is replica list file. I'm going to say some root file and is an open access storage system as well. So something I can access and grab without needing permissions of any sort. So I'm going to do that, and I'm going to say, give it for this particular file, what do we have there? So I'll go ahead and do that. In this particular case, when I run that, I see that's stored on this server in this location. Very useful. So at that point, actually, I could go and then try and download that, either using rucio or, as we'll see in a second, xrootd as well. One other quick thing to mention here as well. Um, this is maybe a little bit misleading in terms of how this kind of is phrased. I could actually just feed this a data set as well. If I said replica list file, give it these arguments, and then give it some data set, say it's that q squared of 3 to 10, one above, it will give us the location of all files within that data set. So if I run this, what I'm going to get is just some list of where all these are stored. Take a little bit of time to run. See my typo that I thought I'd correct is still there. The poop is not involved in this, as far as I know. I should say pipe. What you could do, for example, when you do this, is say, okay, I want just a list of files so I can use them in a script later on. You could just run this and pipe it to a little text file or something like that. So you just get some list of server locations and paths to all of these files such that you can then download them, stream them, do what you like with them. There's some other things we might want to check as well. There can be multiple copies of a file, and you can check whether that's true using these commands here as well. That will just list where those copies are, how many exist, and so on. If you do that, you might see basically that some of these exist on tape storage locations where they're not necessarily actually open access. You need to kind of copy them back from tape before you can get to them as well. Taking a little bit of time here. Maybe cut this command short if it doesn't pipe something out in a second. But this is something you might want to keep track of and might want to use when you're doing analysis, for example. You might want to say, okay, I want to make some list of files I'm going to process later, put it in this text file that I can look at in a later date. I'm going to kill that. And I think in this directory, I do have some file list somewhere. I'll certainly do. So here's an example of something you get from an exercise later. Basically, just something where it's telling us a list of files and the locations which we can use. So the first part of that, though, when we got that output, this bit here, which in that case said root dtn.ese.jlab.org, that part basically just telling us that that particular file is stored on some JLab server. So one of the things that kind of mentioned at the outset in the previous bit is that rucio works kind of seamlessly across multiple sites. An issue, of course, is that the methods which we might use to stream files don't. So as an example, which Sasha touched on in his question, is, say you have some analysis script which just says, great, here's this list of files and they're always on the JLab server, keep just checking them. Next month, they're stored on a different system. Some of them are at Brookhaven, some of them are on some server in Canada, whatever. That's going to be an issue, right? But we can use rucio basically to say, well, where are all these DIDs? What do they contain? Where are the files? Put in some file lists and grab the information there. One thing, though, to comment on is that, if you're completely new to this, if you're completely new to looking at Epic data, finding some DID like this needs some knowledge of what things are like, what Epic data kind of looks like, what kinds of information are in there. Great if you know, not so useful if you don't. And that's where these metadata tags are going to come in the sense that rather than plugging in some obscure set of wildcards because you kind of know what you're looking for already, the metadata tag is actually going to let us filter through and say, well, okay, I want something a bit like this. How can I find it? One word of warning is that these are currently only on DIDs from March 2026 onwards, so some of the most recent campaigns. So if you try and access things a little bit older, you won't be able to use them. Have to rely basically on some of those tricks from before. Um, but if you're looking for something a bit older, hopefully it's because you're kind of a little bit familiar with things already and are looking for something specific. These metadata tags, I will add, this was basically enabled due to kind of a lot of work by Sakib and Emil and others in the software and computing group. So if you're using these and you know, think, great, I can find my data easily, it's really thanks to the people I mentioned there. So what tags are available? I'll run through this, and also these are available if you kind of go to the top of the page on the tutorials, like an extras tab. There's a little rucio metadata tags cheat sheet as well. So after the tutorial, if you're kind of using these and forget, oh, how is it formatted? What's it look like? You can just go back to there rather than hunting through the tutorial to this bit. So maybe just bookmark that or file that away somewhere if you think it might be useful. So what do these look like? As you'll see, these are tags which kind of map basically to chunks of that DID that we saw before. So as an example, one of them is software release. Fairly self-explanatory. The tag just tells you what software release was used in the simulation. Written in the same format. And again, when writing and using these filters, you can use wildcards as well. So you don't necessarily need to know if it's, .2 dash stable. You could just say, give me something which is 26.03.star, and it'll give you anything from the March campaign, right? Is background mixed? Just telling you true or false, the background mixing, machine background mixing in the sample. Data level, simulation or reconstruction. So these bits kind of in the gray text here, these are telling you example flags or things that could be there. In this case, it's literally just these two. Detector geometry config, just telling you, well, what version of the Epic simulation geometry was used. Again, if you were specifically looking for some particular configuration, it'll have some tag applied to it. And you can say, okay, I want something with this particular geometry. Generator, again, fairly self-explanatory. But this one basically is telling you what Monte Carlo event generator was used to generate the simulated data. So maybe you don't know exactly what you're looking for yet, but you just want to look at some output from a specific generator. You could say, okay, I want something generated using Pythia 8. As an example, you could say, okay, generator equals Pythia 8 in your filters. Could then move on to the next, which is just request a physics working group. As part of that name, remember one of the parts was exclusive. Equally, that could be something like DIS, something like that, just telling you what kind of physics process it is. This tag is basically mapping to that. It's just letting you say, well, okay, I want something that was requested by this physics working group. So you could say, I want something requested by the inclusive working group. Say you're a new analyzer to that group and you just want to see what files are available within that kind of realm. You could go and add that tag and see what's there. The kind of opposite side of that for people maybe more interested in detector simulations or who request it in terms of the detector subsystem. Currently, this is just tracking. It's the tracking work group requesting specific simulations or other as the tag. And then there are some here which are again, fairly self-explanatory, but again, link back to that file or DID we had above. So ion species, just telling you what was used in the simulation, what kind of ion was there. Was it a proton, gold, helium, so on. Electron and ion beam energies, again, just plug in, well, what electron beam energy was used. You would just enter it as a number, not 10 GeV. You would just put 10 if you wanted 10 GeV electrons, as an example. There's a NOAA fields for Q squared min and max, or if you're looking at particle gun simulations, there are some tags here. You can say which single particle was used in the gun and stuff like that. So we'll play around with some of these and we'll have a look at them in use cases in the next section as well. As I say, if you kind of go to this at the top, just go to this new tab. All of this is stored basically in this little extra section here. So you can go and look at that. There's also some information on XRD, which we'll touch on in a second. But this basically just has that list of metadata tags there, so you can go and kind of look at it as a reference if needed. I'll post that. I won't click on access it here, but I'll post that in the chat a little bit later on as well. As I say, if you're on the tutorial page, it's just a matter of navigating to it through this extra section here. A few things here as well. Most of the tags in that list are optional. They might not apply to everything. If you're running some physics simulation with a particular generator, it's not some particle guns, so the stuff to do with particle guns isn't going to apply. Some of them are required for all data sets, though. So the ones here are required in all cases. So these will be applied to every single DID. One comment, though, of course, is that just because they're required to be applied to the DID does not mean you're required to use them when you're trying to search. You don't have to include these 5 when you're trying to use these filters, just a case that everything has them applied if you wanted to use these to search. Another kind of weird quirk is that the tags are entered in lowercase. The one exception to this is the ion species. Not fully sure why, that's just the way things are with it. So you would enter it as, see above, like he free the uppercase H there instead of lowercase on both. The others, though, for example, with the physics working group, it's all lowercase. Okay, how about actually using these? So fairly straightforward. You just run that did list command and then use this filter where you just say tag is equal to this or whatever logical kind of argument you want to use there. Again, you could say greater than or equal to 10 is an example if you wanted to run for maybe the beam energies. This maybe could be greater than 10 if you like there and see what's there for that. And then you have to give it a scope. In this case, it's again epic. So we could, for example, run this command here, which just says, okay, apply the filter and check the metadata tag and just give me things where the electron beam energy was 10 GeV for that DID and search within the entire epic scope. Can run that and see what we'll get. It's not particularly specific set of filters, so probably going to get quite a lot still. Can run that and see what we get. And as I say, we get quite a large list. It's not quite that huge list we had to begin with, but it's still quite a bit to sort through. We can apply that short org command as well if we want. But we see here there's lots of different options, lots of different things sitting in there with 10 GeV electrons. So some 10 on 100 DIS events there as an example. Some semi-inclusive deep elastic scattering events as well. Lots of different campaigns there as well. So, okay, great. We've already filtered through and maybe we could pick our favorite from them and run something with it. But of course, we don't have to just run one filter at once. We can also apply multiple, right? So we could say, okay, I want 10 GeV electrons on 250 GeV ions. And I'm not going to specify the ion type. That's basically telling us it's going to be protons as well. And we can see what we get. Hopefully it's going to be a shorter list than there. And indeed, it is a bit shorter. This time we just have almost just a page full of things there with some 10 on 250 GeV events. This isn't rigged, just happens that one of the beam energy combinations run is this DEMP one, which I guess used as an example, and it's something I'm familiar with. But as we see, there's other samples there as well of 10 on 250 sitting there as well. We can combine and keep adding filters as we like, and also add wildcards in there as well. So as an example, you could add, basically here, you want to see what's there in, again, I'm going to say 03. It's something in the March campaign, but you don't know what's there. You can run that, see what DIDs are in that list. And again, this time we get some list of stuff, 10 GeV electrons in the March campaign. Stick that ion beam energy back in as well if we like, change the logical expression, see what we get out from it. Just keep in mind, as a disclaimer, that these tags have only been applied from March 2026 on. So if we're trying to search for things older than that, we're not going to get any output there. Okay, so I think we've definitely had enough, and my throat has definitely had enough for me just talking. So at this point, we will move to an exercise, and I think I'll stop sharing. I will post in the chat the link there in case anyone doesn't have it or didn't find it. But the exercise here, which I think will give people 5 or 10 minutes to have a little bit of play around on, say 10 minutes from now, and we'll come back to this, um, is to use these tags, find the DIDs of the latest events with the condition specified here. Once you found it, print the full data identifier. So it's going to be some data sets that you find here. Print the list of files and see how many files are in that data set. You can take a look at the name we used when we kind of introduced the IDs here, to give you an idea of the sort of filters you might want to use, things you might want to apply. But there are some hints in the formatting of this as well. So given some Q squared range specified, told it's electrons on protons, a few other bits and pieces here. It's the DMP events as well. The back again, so you can start to see how you might try and filter this down. One quirk, of course, is that this maybe is something you need to double check and try and find what the latest actually is in this particular case. As I say, I'll give people a few minutes to try and play around with that. Good point to advertise as well. I will post this in the chat. Of course, there is the Mattermost software tutorials channel. So if you have some output that doesn't make sense, or you want to ask questions, you can go ahead and post it in there as well. I'll take a look at it, and I think maybe Sasha's, I know, on the call and in the tutorial, have a look at it as well. Of course, Sasha has a problem. I'll have to do the answering for his problem, but do post there, share what you get. If you run into any issues, just let me know, and I say I'll give it a few minutes for people to try that out. Sorry for the bit of back and forth there as well. I was just trying to get my controls back so I can mute myself a little bit as needed. Okay, with this, well, I mean, I can run through sort of solutions to this, if people like. But I say for this one, I think it's relatively straightforward. Just a kind of quick look at how we can maybe play with these things and use it. I might leave it till the end, or can maybe just paste it in the chat at the end as well.
Do you want the most recent one?
Yes. So as I say, that's maybe the slightly tricky thing with this, because actually I don't know at this point if the March or April is the latest for this. So that's maybe something as a kind of first thing to check, or once you find the rough DID, you just see, okay, well, what's the latest batch for that? Question in the chat from Sasha, why does it always need to scope epic? I guess if you just put good question. I don't actually know if it just works if we didn't provide the scope or if we just had the wildcard there instead. Yeah, maybe we just try that. Curious about that. It always does want the scope. Whether that's something that's to be set automatically in EXE shell or not, that's a good question. Straightforward enough to, I think, just make sure you keep including it. I'll give people another minute or two. Just keep in mind as well, the second part of that is just check since what you will get is some data set, uh, print the data set and just see how many files are in there. In this case, it's not really, don't need to put it to a file or anything like that. Just have a try at getting that information and seeing what it has. Yeah, I'll give it another minute and we'll maybe briefly talk about solutions to this as well. And I'll reappear for everyone there as well. Okay, so maybe run through some of this. People can keep trying and playing around with things in the background as well. But I'm just going to run through maybe that first little bit. I am going to say, okay, what the first part is saying, find DIDs of the latest campaign. So I am going to say, okay, plug this in and say software release equals 26.0 start. And we'll see what we get with that. Because coming into this for the first time, we have maybe no idea exactly what campaigns have run recently. It's May. Maybe we actually expect that there's a May campaign there as well. Going to run that, see what we get. Oops, yeah, missed a space. The great thing about live typing it. Okay, so I've run that. Okay, I see 26041 is there. 26031. Don't really seem to see anything higher. Maybe, of course, add a filter and say, well, is anything from May there? 2604 seems to be the most recent. Nothing found. So the latest files in this case are maybe in the April campaign. So yeah, plenty of stuff in April, but are all particular files there as well. So that looks like the latest. We're going to try and stack up a few more filters, and we're going to use ones basically to try and pin down that data set. I'm just going to cancel my timer so the alarm doesn't go off and interrupt me halfway through. I'm going to say, well, I wanted 10 on 130, so I'm going to say electron beam energy underscore GV is equal to 10. Ion beam energy GV is equal to 250, wanted in this case, yeah, 10 on 250. I'm also going to say Q2 min squared equals 3 from that as well, and see what we get. So it looks like in this case, we do actually have something there. We have something in the 26041 campaign. So it looks like something has run for this set of files there in this campaign as well. So great. What I'm going to do now is just see what's actually in that set as well. We did content list, say short, because I don't want to get the full set of information. And then I'm just going to provide it with that DID as well. Although actually maybe this is telling us that's not there. Let's give it a try anyway, see what there is. There we have it. We have some files there for that particular campaign. So stuff is there. Scrolling up, I see this is number 0362, seems to be some increment. And it's going up. So we assume it starts at 0000. The latest one there is 0366. So we can see maybe there's 367-ish files in there, 366, depending on whether it started at 0000 or 0001. That actually is new since I checked that last week. I think that's not all of them. I think the April campaign is probably running for this particular set as it is, because when I did this last week, the latest was actually only the March campaign there as well. So a discovery, I guess, as we're running through this. So just as a quick example of as how you can use this, you might note that when I did that, actually I didn't bother specifying the Q squared max. It's cheating on my part a little bit because I kind of already know the way these files are organized in this particular case. But of course, we could also add that as well and say that and see what we get. Hopefully it will return the same one it does in this particular case. As I say, cheating a little bit because I already know that the max Q squared in that range is it only has 3 to 10, 10 to 20, 10 to 20, and so on. Okay, so great. We have lists of files. We can find DIDs. We can see what's in a particular data set, get the location of them, and that's great. But generally, we don't just want to know where stuff is. We want to do something with it, right? Um, and really that's the next step. Once we find the data, we want to use it in some way. For simulated data, generally the reason we want to find it is to analyze it or take a look at it in some way, right? Well, what's happened when we run this particular event through the simulation? Using Rucio, we can download things, containers, data sets, files. We can do that quite straightforwardly. We could just say, Rucio download and then give it the DID for the file or data set or whatever. Big warning and disclaimer here. I am just going to give it the DID for one file. You can give it the DID for a data set or a container, and it will go ahead and download that entire thing. Generally, that's maybe not what you actually want to do. So before just downloading an entire data set, really ask yourself, well, do you actually need all of that locally? You probably don't for most use cases. You probably just want to maybe download a single file or a group of files locally and test something, right? More generally, you would want to just stream the files, which we'll touch on in a second. But we can do this, and we'll see there's a slight quirk with this. So, okay, great. It's doing something. It's grabbing it. It's going to try and download it. Fantastic. And it's done so. It's downloaded the file. Great. Didn't even take particularly long. We've got 16 megabytes per second. My Wi-Fi is behaving itself today because I haven't bothered to plug in my Ethernet. Um, Great, it's downloaded it. What is it called, the file? And this is one of the issues that we'll see quite quickly with Rucio is that DID, as we said, looks like a file path. So how is it downloaded it? See like this. Well, actually, it's downloaded this in a fairly obtuse manner where it's just downloaded that thing quite literally as Rico 26020, blah, blah, blah. So my single file is now nested several folders deep. You keep hitting tabs and still only file in there. But when I do that, no, great, it's all the way down here in that directory. And then it's just called that thing that I wanted originally. Not particularly useful. And as far as I could see, Rusio, there wasn't really an easy or nice way to just get output. If you're doing a CP command, you maybe say, okay, copy this thing to this name instead. So actually, that's where this recommended workflow of instead, once we know where the thing is, use xroot to grab it or to stream it. So I'm going to clear that. And instead of this, I'm going to say, okay, I know where that file is. I could check the location. I could do my command above to see which server it's on. And I can instead just run this command as well. So xroot, again, if you want to take a little bit more of a look at it, you can take a look at that link. It's a little page in the extras again, just telling you a little bit about what xroot is, how it works, how you can use it. But one of the nice things is, in particular, this command to copy it is a little bit more intuitive. So rather than copying this horrible nested set of things with all the folders, in this case, I'm just saying, just copy this particular thing. I think there's actually an extra slash in there, which I'm going to have to get rid of. See, get rid of that. Download that thing. Oh, fortunately, I've already downloaded it. Let's quickly just change that to that file. See if it works.
Can I ask you, how did you know that it's on JLab with this prefix editor?
Because again, a little bit cheating because I've already done this. And in this case, because it's a February campaign file, they were all on JLab servers then.
But
Now,
that's very insider information.
Exactly. So cheating a little bit. Really, what I should do is say, you know, where is that file, right? I mean, okay, let's go and check it. Actually, that's a maybe nice example. We're going to quickly change that as well from that campaign to, again, a little bit cheating here because I know it's in the March campaign. Where is it in March? So it doesn't actually exist in that particular case. Sure why. Maybe it's on a zero. Maybe this little example isn't going to work as hoped. Okay, we need to go and find it first. But yeah, in that particular case, it was sitting on the JLab servers, and I kind of knew that in advance. Really, though, once we found the DID we wanted, we would want to check where it actually is and maybe make some list of files from it as well. Clear that and pretend we didn't try that. So yeah, in this case, we can copy it. That again kind of bumps into the issue where if you were just using xroot D, the issue indeed is you need to know which server it is ahead of time, which is, you know, unless you're cheating like I am here, not great. You could also, if you know all of the possible servers, start trying to hunt through it. But again, as more servers get added, that's going to become a bit more tedious as we want to keep going through it as well. A few other things as well. One of these is that once we know that path, and if it's open access and accessible, if we're running something in the IC shell, we don't even need to download this thing locally. We could, depending on how we're analyzing our data, just say, great, in the little root script, the macro, open the file at that path. And again, we've got the server in there already. And it could just say, okay, great, yeah, I've got that file. I can find that, stream it, do whatever you want with it and access it. Same thing if we're using uh, Python and we're using uproot, you can do the same thing. File path is this thing, it's on the server, it's sitting here. You can go ahead, plug that in and run it. And again, same thing directly with pyroot. You could do that even if you don't want to use uproot to open it. You could just say, open this thing, open the file there and take a look. So we could check that, and I'm just going to do one version of this. I don't want to go through all of these, but if I just make some little script called test.c, I hide my controls here so I can see what I'm typing. And I'm just going to, again, I've already benefit of having prepared this is I've already got my little script. Just going to run that with root. So that file, let's just quickly show that it does indeed just contain that. We see basically I've just copy pasted that there as well into it. So all this is going to do is open that file. It's going to say, okay, open the root file, get the event tree from that, and then get the number of entries in that tree. So now I'm going to just run that and see what it says. 711 events, great. So we can see if we want to run that, we'd have 711 events in that particular file. Since it's already there, why not? I'll run the Python version of this as well. And I believe it's just going to be s.py. We'll hope it also says 711 there as well. Again, 711 events. All it's doing is the same thing. I can't remember which of these two versions I used here, but again, output should be identical between all of them. So great, you can, once you have these things, get the information easily and do stuff with it. Manipulate it, process files, stream them, download them, do what you like. And again, one of the key things earlier, so when we ran that command, tell me where everything is, basically, instead of saying, where is that thing? Instead of saying, okay, tell me where one particular file is, we could say, where are all of the files to that data set? And using a standard sort of pipe command, put all of those in this text file, which you could then process using a script as an example, right? So a few little things before we look at some use cases. Rucio works with these things called DIDs, data identifiers. That could be a single file, it could be a collection of files in a data set, or it could be a collection of data sets in some container. It doesn't really care. It just talks about all of them as data and has data identifiers for each of them. For Epic and for the Epic scope, they look like a nested file path, but they're flat. So be careful with stuff like DID list and then, Epic, Rico, Star, it's going to give you literally everything that matches that, not just kind of that level of the folder. So be a little bit careful with it. And if you're going to use that rather than using the metadata tags, you have to be a little bit clever of how you kind of structure your wildcards, basically, is the way to kind of express that. The tags, though, you can use to kind of quickly sort and find the data you actually want. So generally, going into this, as we'll see in the next bit where we look at some use cases, you probably have some rough idea of what you want. You may not know exactly where it is until you start to get a little bit more used to this. You might just know it's some certain classification event, some certain beam combinations, something like that. And you can use those tags to start hunting through and finding that information as you go. Once you find it, with Rucio, you could download it if you like, but as I say, it has this slightly silly issue of its download command. What we'd recommend is that you use xrootd to just download it. And if it's more than like a handful of files, and unless for some reason you really need to download them all, just stream them instead and run your script streaming these things, such that you don't have to keep hundreds of gigabytes of this data locally and do the same every time you want to get a new simulation campaign, as an example. Okay, so we'll look at a few different use cases. There are some exercises in each of these. We'll see how far we get. I don't want to stay forever on this. We can kind of stop at the half hour, so we've got about 45 minutes, which, if you believe the timings, make sense here. So here we're just going to kind of look at a few use cases in terms of, generally how people are interacting with the simulation campaigns. Examples of kind of carrying out some common tasks with each of these are going to be included here as we go along as well. So two distinct use cases we'll look at first, which are basically someone coming into this completely fresh. They just want to take a look at some EIC and epic physics, but they don't really know the details of what's there. So that's this physical analyzer, this kind of novice case that I'm exploring here. So here, the use case is really, you can picture whether maybe this is you, or maybe you can just picture this. Someone new to analyzing epic physics data and wanting to try and just look at some physics process. Maybe you're just kind of interested in this and want to see, okay, well, what do DIS events look like at the EIC? What kind of stuff is in there? Can I take a look at some DIS data as an example, right? They maybe want to look at some specific process. Maybe it's DIS. Maybe they really want to go and look at some particular exclusive process. Maybe it's those DEMP events. Maybe it's deeply virtual Compton scattering, something like that. They maybe have a specific physics process in mind they want to look at, right? Could just be that they want to look at some specific beam combination. What sort of things are available in this kind of period, these kind of beam combinations, or maybe even as simple as what sort of simulated data is available for electron on helium free. Who knows, right? Maybe that's all they want to look at. Maybe they want to then get some of that data, take a look at it. Well, what does it look like? What kind of things are in there? What does an epic file look like? What does a simulation output file look like? What does a reconstruction file look like? What information is there? How can I analyze it, right? Perfectly reasonable and understandable. And in this use case, this actually is maybe one way you want to download one of those files, or a small number of them. Grab 5 or 10, nothing more than maybe a gigabyte of stuff. Take a look at it, see what's in there, maybe write a little analysis script and just see what's in there and try a little sample analysis. You can then maybe expand it and build upon it when you know what the files are there, what things are like, what sort of maybe cuts or selection criteria to apply. You can then move it on to the next stage and run it over the full thing. To find the kind of files they're looking for, quite a few of the tags kind of maybe stick out quite quickly in terms of things they might want to utilize. So they might want to look at just, particular software release. They probably just want the latest files, right? Might be they want to look at something a bit older, maybe something doesn't exist in a particular campaign, who knows? Probably want to look at a specific type of process, maybe just in general, might not be as specific as I want to look at this particular exclusive event channel. I'm going to keep coming back to exclusive events simply because that's the one with, in my mind, the most specific individual channels that are quite different. Just as an example, but maybe they know they want to look at like DIS events as an example to begin with. They might know they want to look at specific beam energy combination, or again a specific ion species. Maybe it's kind of just light ions in general. I know that's a particular study group as an example. They just want to look at, say, deuterium and helium studies. Or maybe you only really care about gold. I don't know. Maybe you just really like things involving gold, and you want to look at that. You could plug that in. You could say that's the ion species I want. So it's an example sort of command they could use. It maybe is something like this, right? They plug in, I want a DID list with those filters applied. Might use all of them, might use some subset of those, plug in the numbers, and then in place of, these values, put what you want. Doesn't even need to be equal as we saw, could just be some logical expression. Maybe you want to look at, high center of mass energy stuff. So you want electron energies or ion energies over a certain value. Great, you can plug that in and you can say, okay, great, filter out for ones where that's true. You can plug that in, and just as a reminder as well, just in terms of the way things are generally written, and the kinds of beam energy to sort through. So again, if you're completely new to this, typically the way in which things are written, and as you'll see, it is kind of electron beam energy on ion beam energy. So 10x 100 is 10 GeV on 100 GeV, as an example, or could be 10 on 100. Just depends how people write it. This has to be updated given recent news. The electron beam energy is typically 5, 10, or 18. Soon to be also 9 is going to be a typical beam energy that's there. And the ion beam energy is typically something like 41, 100, 130, 250, 275, as an example, for protons at least. For other ion species, you might see other values in there as well. Again, you can use wildcards, of course, and can use greater than different logical expressions. Interesting, yeah. So idea about using aliases. We'll maybe pop back to that when we get to the exercise as a discussion. But yeah, just as a kind of this is the kind of example of the sort of things to look for. As I say, that will be changing a little bit, and there'll be a new electron beam energy adding in there. Um, but you could go ahead and run those sort of commands. Um, Again, you just run that, and once you find the particular DID you want, say you're hunting through, you find the one you want. You can see what's there and you can get the location of files in the data set using those commands. So you could say list file for the data set, tell me where all those things are. So I'm going to say that and just say, temp.txt or something like that. Dump them all to that file when you run the command as an example. And then if you find one or find a bunch, you could then say, copy that file using xroot D and put it on my local system to take a look at. So where that file path is just one of the specific ones from here, there. So again, time for an exercise, and I'll give people again 10 minutes or so to take a look at this. I'll answer or discuss Sasha's question in the chat there. I'll give people a little bit of time to look at this. Using the latest and using the tags above, try and find the latest available data set for neutral current DIS, so NCDIS, with 10 GeV electrons on 130 GeV protons. And when you find it, download one file from that data set. Just pick one and download it locally. Just check that you can do so using XOR or DCP, that command there. Just to kind of, I guess, because again, if people aren't familiar, neutral current DIS, because of the way this is sorted and the way that tag is written, this request at PWG DIS events or deep inelastic scattering falls under the purview of the inclusive working group. So as the argument there, you could put inclusive as an example and see what comes up. So I'll give people a little bit of time and I kind of give you one of the tags you maybe need for free there. But have a look, play around, use the tags suggested there. Feel free to try others as well, and have a go in terms of running that. Sasha's question in the chat was with regards to alias functions and metadata tags. Interesting question on that is actually one of the things I haven't really checked is whether, as an example, wildcards work on the tag name. So actually that's something I might just check quickly. Not sure how much this is going to do in terms of narrowing it down. No, it does seem to want the full thing. It doesn't seem to like the wildcard there as well. I guess the tricky thing with that, Sasha, is that, for example, ion is a trickier one because there was also ion type and ion energy are two distinct tags. So you'd have to be have something like ion E or something like that, I guess. But the idea I think behind each of the tag names is to make them as sort of self-descriptive as possible. Um, so it should hopefully be unambiguous as to what sort of thing goes into it. Okay, I'll give people a few minutes to take a look at that, and we'll revisit that with the solutions. Again, feel free to post on the Mattermost, the software tutorials Mattermost, with solutions and input as well.
Can I ask you, what is your square range for exercise? Because there are many.
Good question. That one I think I'm deliberately leaving up to you to pick. Um, take your pick, find whether take your pick, see what's available, and grab whichever one you feel like. All you really want to do is grab one particular file from here, which indeed, if I'd scrolled down on my notes, the solutions is there. So yeah, we weren't told, wasn't specified, so just go ahead and pick one. Sasha says you'll probably see there's quite a few different Q squared ranges for this particular data set. And again, I'm kind of curious as to whether, since I put together my sort of solutions last week, whether there's actually newer files from the April campaign for this or not. I think when I tested, there was only March campaign files available in this particular case. Okay, a few more minutes left. You'll to try playing around with it and grabbing a file. I am just going to feel free to just ignore what I'm typing out on my screen as well. Just going to start typing in some of this just so I can actually kind of get some rule and show something out from it as well.
Can I ask you something?
Yeah,
So I did find the files, but I cannot copy them because uh, it's not a valid deed to many columns. It's on Epic XRD1 from April campaign 2604. I pasted the comment
interesting.
in the chat and it didn't work for me.
let's take a look. Let's see. Aha.
So first, I found the file using this command.
Yeah. You find the RC. Yeah. Got ones from the April campaign. Yeah. Yeah. I would say I try. Did it work with XRDCP or not?
Uh, Not yet.
Because certainly, yeah, rucio downloads, as I say, isn't great for a few reasons. And if it isn't working flat, that's another one of them. If I'll just try and find a file as
Yeah,
well.
it worked. It worked. Okay.
Okay.
So the CPU worked.
Okay, another good example then of why rucio download is maybe not the tool to use. Okay, so yeah, in terms of finding these, I plugged in basically a DID list command with a couple of different flags and arguments there. So in this case, I didn't, again, don't know necessarily whether the March or April campaign is going to be most recent, because despite the naming, both are actually ongoing currently at the minute. There's some March files I haven't run, and equally April is running kind of in parallel. And as we see, there are quite a few different ones which match it, but there do appear to be some ones in April. So we're going to pick one of the April ones because it says find the latest. As Sasha asked as well, there are a couple of different Q squared ranges. You see 1 to 10, 10 to 100, 100 to 1,000, 1,000 to 10,000, and so on. We're not necessarily told which to use, so we can just kind of pick any here. And I'm going to go ahead and pick that one there as well. So once I've got that, what I'm going to do is use this command here and just say, well, okay, what's in that data set? And where are all things in that data set? So I'm going to plug it in with that particular one and see what we'll get. It doesn't seem to like it. Oh, because I forgot the scope. That's why. And if this takes too long, what I'm going to do is kind of step back a little bit and just say, okay, well, what files are in that data set and just give me the path to one particular file. I would say typically when you're doing this, you probably wouldn't just print them all to screen like this. The utility of it really is in kind of pasting it to a file or something like that. And once you then have that list, you can then iterate over it and run over it, as we'll see in the next little section. Okay, I'll give this another 10 seconds and I am just going to say, okay, just give me the one particular file. Ah, there we go. So lots of stuff here, tons and tons of bits of information. I am going to say, let's get this last one because it's easiest to copy. Copy that locally and see if it complains. Happy to do so. Slightly bigger file this time, 250 meg. I'm just going to download that and paste it locally with the same name. But again, not in some nested directory. So now we have, they're sitting on my computer, taking up some space. Don't actually really want to do much more of it at the minute, so I'm just going to delete it. Delete that one as well. But nonetheless, it did copy over and we have the file sitting there so we could analyze it and open it and do what we like with it at that point. Okay, so fairly straightforward use case. Something quite typical in terms of just testing your data, probably something you want to start with, to be honest. Find what's there, copy a file, open it, see what's in it, and just check things look okay, stuff like that. Particularly if you've modified some analysis script or you've just written one and want to test it, you probably want to only try a few at once. The second use case, though, which I'm kind of describing as kind of experience case, can maybe think of this more as kind of just a bit further beyond the kind of testing side of things. In this case, we're going to consider someone a bit further down the line where maybe they have a channel they want to analyze, they have some script already that they want to run on the files, and they want to run over a huge number of files, maybe probably even the full data set, right? And they want to do this for some specific physics process they care about. For those in physics working groups, this use case is fairly common, right? I mean, say the inclusive working group, they want to process all of the latest simulation files, get some output, and get some physics result from it, right? So their requirements, what they need, probably going to need reconstructed files. They really want to run a specific process or group of processes, want the latest files, and want specific configurations in terms of the collider energies and ion species, things like that. They might also specifically want data sets with machine background embedded in there as well. So they might want to see the impact of machine background, things like that as well. So types of tags they might use, similar to before, but they might also want to specify a certain generator. They already know what process they want to look at. And this one is something that really helps narrow down what you're looking at. As an example, for exclusive processors, each of the different processes generally have their own event generator, and it's a real kind of quick way to narrow down which one you're going to look for and which one you're going to find. They might also want to specify a certain Q squared range there as well, along with the ion species. Maybe they already know they want to look at specifically protons or something as well. Since generally they want to look at a large number of files, they probably aren't going to want to just download all of them and run them locally. So it's kind of unlikely that's going to be what they want to do. And it's really not recommended necessarily that's what they want to do as well. They're probably instead going to want to stream their files in their analysis script. And they can do that using the examples we saw previously. They may also want to process a full data set. So rather than just a sort of subset of files, they might want to say, take this entire list of things and run all of them. Add them all to some T-chain or, do some analysis with some big group of them. So with that in mind, what they might want to do once they find their data set is pipe that to some file list as an example. And that maybe is the input to some analysis script. Quite common. It's actually something I do in my analysis, and I think I've seen other scripts that do something very similar, where they say, okay, open this file list and just go through it, where every line in that is a file to process and add to the chain as an example. So they could do that, get it, and make some little script, something like this, where it just says, great, go through that, add them to the chain, or do something with them, right? In this case, you don't need to do that necessarily, just see what's in each one. You can do something similar using Python, etc., and run and look at the same thing. The examples listed there, the kind of snippets of code, they're restricted to basically try and print out only the first 5 lines in the file we created, just so you don't have some huge info dump to screen, or it doesn't take forever to kind of stream these things as well. You can comment that out and change it as you like as well. If you wanted to just say, great, actually, this looks very useful. I want to do something in my script and just copy paste it in. Okay, so this section really is the sort of exercise section. So the exercise here is kind of, again, using those tags, find the latest available data set for, in this case, deeply virtual Compton scattering, DVCS events, using the specific event generator, the Epic event generator, for 10 GeV electrons on 130 GeV protons without background included in the files. And then once you've done that, stream one of the files in the data set, find out how many events are in there, print all of the files in the data set to a text file, and stream 5 of them and just check the total number of events in all 5 files. I would say, this is set out as in you do 1, then 2, then 3. 1 and 3 you can kind of do simultaneously once you have the file list if you like. It might be the easier way to do it. Really up to you how you want to kind of approach that. So that's the little task. I'll give it, again, 10 minutes. I think that the first stage of this in terms of getting information out from Rucio, very similar to the last few examples. The difference really in this one is actually starting then to stream them or do something with them. Grab the info, process it in some way, right? Snippets here should help, and you can kind of use those as a starting point. And equally, whether you want to use Python, whether you want to do it in roots or use some other approach to do it, really doesn't make too much of a difference. Kind of use either snippet to get at that. So as I say, I'll give that 5-10 minutes, and then I'll maybe start to kind of work through this. Again, that first step is very similar. Just try and find the DID first. using some of the sorts of arguments and commands we had from previous examples. And I think Sasha had, you could use those as starting points in the Mattermost channel, um, ones that kind of work for those tags. So you don't have to keep copy pasting the tags in every time. Just a few things to keep track of in terms of, the specific set of events we're looking at in this case.
Is there a way to limit the number of files shown, like
When
a
doing
head?
the print list,
Yes.
good question. I'm not sure there is. There might be some set of arguments you could do to limit it. Um, Certainly, I guess you could with some post process. If you piped it to a file with some post processing of that, you could just trim everything to the last five entries in a kind of couple of different ways, right? Last or first, or some subset of five, either way, right? Yeah, I mean, there's either process the file list after you've done it, or in the accessing the file list, kind of just limit it to five in the ways we've done here. Um, yeah, so I say a few different ways and approaches to do that. Within the first command, though, actually, it's a good question. I'm not entirely sure if there's a way specifically to do it there.
And also, can we use the metadata tags case insensitive?
I think they are case sensitive generally. So again, with this, so this is a bit of a tricky one where, yeah, the event generator is written like this, but because they're all lowercase, the generator is epic lowercase. A little bit annoying, which I think, again, feel free to just ignore me kind of typing away in the background on this, but I can just quickly test that as well, actually. See, as you might see from this, one thing to keep track of here is that actually, when we run this, the generator in this particular case actually does, there are a few different processes which have this generator used. However, just kind of when you're looking through this, you should end up with just a small subset of them. Just keep in mind that it's only DVCS that we want. So there's a few others here you can see. So for example, DVMP, don't want this process. And equally DDVCS, we don't want in this case. That's double deeply virtual content scattering. Ends up being an accidental tongue twister, but I guess that's just because of talking for 2 hours.
So no backgrounds means no afterburner conversion.
Not quite. So Afterburner is just an application of beam effects. So typically when event generators are run, they just run with no crossing angle. Afterburner applies that. No background is a bit more specific in that that removes, so some events are mixed with machine background. So these are samples where they have beam gas interactions mixed in, where there'll be um, one background signal per event or something like that is generally the way they format it. Give it another few minutes. This is one where I am because I don't want to type these commands in by eye, so I'm sure I'll make a typo. This is indeed one I've done earlier, so I'll give it another minute and then I'll open up my little file of my solutions, and I'll then try processing a little script I've kind of made in advance as well, which is I think actually sorry, it's not in this directory, it's in a different directory. So indeed in here I've got a little script already written which is going to do this.
Maybe programming the number of events is not so straightforward for this short tutorial.
Yeah, I thought I didn't want this to be a playing around with root tutorial, so just I thought, okay, I'll just have that in there as well, so people can just copy paste it.
Maybe, yeah, or just comment it.
Okay, so say I'll give people another minute or two. While I'm there, I'm just going to find the in my little exercise solutions here. I'm just going to find the command I need for this, which is from, which is this one and the one below that. So the subset I'm going to use is I'm going to use this DID list and apply the filters shown here. So I've got software release is, again, I don't know necessarily, and it probably has changed since last week. I think it's added space in there, so bear with me. Um, don't know whether March or April is the latest in this case, so I'm just going to check all things from recent months. Um, DVCS is an exclusive event process, or exclusive process rather. So I'm going to put the request to PWG as EDT, exclusive to tracking and tagging. And we also wanted 10 on 130. So I'm going to just try that and see what we get. So I actually get quite a few different things. I'm going to plug in there as well, generator equals epic, narrow it down. And now we just have three different things in here. So we have DVCS from April, the bottom, DVMP, and then DVCS from March. So actually, again, this has changed since I last did it. I'm going to adjust this slightly. So I'm going to make a second list. Now that I know my DID, I can run the second command I had up above, which was, okay, let's make some file list of that and paste it out to a file as well. So I'm going to change this. I'm going to say, do it for this data set and pipe that to, I'm going to call it something slightly different. Ignore the alarm. Version 2. So I'll run that, and what it's going to do is shouldn't get any output screen. What this is going to do is just run that command, check all of the file locations of files in that data set, and it's going to add them line by line to the file specified there. So DVCS file list, rucio exercise 2, version 2, the formatting of that, call it whatever you like. Clearly, the issue, of course, is when you run your script, just make sure you change the file name if you've specified it there. If you've done it sensibly and plugged in that it needs some argument which you provide, which is the file name, you have that issue. But if you've hard coded it, then you'll of course have to make sure it matches. Okay, so let's run. What's that look like? New tail. that and see what's in there. So great. I now have some list of files for the DVCS events. So they're all sitting in there, 745 of these things sitting there, and I can process them. So I did also make, as you saw, a little script for this, exercise tutorials. I'm going to open that quickly. So as you see, it did have the file hard coded, so I'm going to change that to version 2 and I'm going to run that. So much like the one there, what it's going to do is just open that, look through line by line, grab the file, check the number of entries in the tree. It's going to print some little statement, which is just the events in the tree from each file. And it's also going to add some counter, which is the total number of events. So doing kind of tasks 1 and 3, where we can get the number of events in the first file, because it's going to tell us, and it's going to tell us the total number of events across the 5 files as well.
Is it 8,710?
It was, I think, when I last run it. Well, actually, no, because I ran the April one. It was, sorry, the March one, it was 8,310. So let's see what I get with the April ones. So 1742 files in each events in each one. So 8710 in 5 files. So yes. So actually, it looks like between March and April, there's slightly more events per file, which is interesting. I'm not quite sure why, but roughly 80 or so files, events more per file. And again, shouldn't really matter how you do that. Examples of how to get the numbers in each in the other ones as well, so like Python, things like that. That's just a straightforward example. Generally you wouldn't necessarily want to grab that. You might want to know that total number. For example, if you're running your analysis script, you might want to use it as a kind of progress checker or something like that. You need to know how many events you're going to be analyzing in total. Um, multiple ways you might want to use that. But more generally, if you're doing this as a sort of route-based analysis, what you're probably going to be doing is adding those to some chain. You'll say, okay, I want to analyze this tree across all these files, and you just add those files to that. So it's analyzing this big string of them, right? As an example. Okay, so one last little use case, and then we'll wrap up. And I think given the time, we're 10 minutes from the end, I'll maybe just introduce the use case and leave the exercise for people to give it a little try afterwards as well. So the final use case, I've kind of bundled a few together here. Basically, because at the minute, in terms of the simulation campaign files, these are kind of one case rather than multiple. I think the sort of files you might look at are kind of grouped together here as well. So in this use case, what I'm picturing is really someone who, rather than trying to look at some specific physics output, maybe you're not interested in the output of DVCS or whatever your favorite process is, you actually just want to know, how is this detector performing? Or I've made some change to the reconstruction algorithm for this thing. How does it perform month to month? What's changed, right? A couple of different ways in which you can picture that. Maybe you want to optimize that algorithm, tweak it as underlying software changes. Maybe you realize that you're building a detector and the price of your SciPMs has gone up 100 times and you can't afford it, so you have to redesign it or something, right? Might happen. Unfortunate, it might happen, but you want to go and change things and see what happens as you maybe regroup your output, something like that. You make the change, you want to see what's happened, it's in the simulation campaign, and you want to track that. Similar sorts of things. Depending on what you're doing, you might just want the reconstructed output. You might want to see, okay, well, the algorithm hasn't changed, but the underlying software has. What impact has that made in the reconstruction level output? So you might want that reconstruction output, or you might already know something is different at the simulation level. You've tweaked something. Again, maybe it's how things are grouped, size of a detector or crystal or something has changed. You might want to look at a simulation level and see what's happened there and what effect that change has had. So you might want not the data, the sort of reconstructed data level. You might want the simulation level instead. So physics analysis probably doesn't want the simulated level information, but this might. Again, because you maybe don't actually care about a specific physics process, you maybe just want to look at some particle gun studies instead, and they all run. Classic example of that is you want to look at PID performance, so particle identification performance, where you just have particle guns firing kaons into a certain region of the detector, right? Straightforward enough. You want to see how well you can distinguish kaons going to that detector and leaving signals there. And a kind of classic and straightforward use case there, basically. And you might want to just keep checking, well, how are things changing between software releases? How are things changing between geometry configurations as well? If there are major underlying changes to things. A few different examples there. So in this case, types of tags you might use there, software release, data level, the requested DSC, all of these sorts of things as well. As I say, at the minute, this one is just tracking or other. So some things are tagged specifically as tracking DSC information or requests. But in future, you can maybe see that that might be expanded with other working groups of DSCs wanting specific simulation campaigns run. So key tags that you might use included there, and you can play around with. Some of these, once you specify the particle, you might not necessarily care where it's going or what momentum it has, things like that. You might just want kaons as an example. Equally, you might not care what the particle is, but you just want stuff going in a certain theta region or something like that. Tags that you can use to sort of sort through that are all there. And again, as an exercise, fairly straightforward. Want to just give a little try of after this if you want to play around with those tags as well. Okay, so I say I don't want to, fortunately, maybe not quite the time for that. It's similar to the other ones in the sense it's kind of just plug in those tags, try them out, play around with them, stuff like that. Discover all the fun quirks that come with those particular tags as an example as well. I I'll wrap up instead. And I think that's kind of the introduction to using Rucio, some example use cases, scenarios, and hopefully maybe some snippets of code that you can grab and use and adapt to your particular use case as well. In particular, grabbing the files or getting some list of files, stuff like that. Um, Keep in mind that this is quite new. Those metadata tags, as I say, are only applied from March onwards, but they will be kind of rolling onwards and going forward. New tags may be added as we kind of find that they're needed. We put that sort of subset together as something that could try to grab the information that's available now. Going forward, maybe we need more. Who knows, right? It's a case of it'll evolve and more will be added. Um, if you have any suggestions of things that you would like to see, I think Sasha had some in the chat, for example, there's other aliases we could use, things like that. We can try and implement them, take a look at it and see what we can do with that as well. And as people start to use this more and get more familiar with it, I'm sure people will find things that I don't know about, or as we've designed this, we don't know about generally. And if you find kind of cool things or useful bits and pieces, do let us know and we can add them and incorporate them here as well. Feel free to post them at most in software tutorials if you have examples, bits and pieces. Sasha's just posted in the chat the MCP server as well. And just a few things to keep in mind before you start just downloading whole data sets. Do have a think about whether you need all of them. Do keep an eye out for whether the files are in multiple locations. There could be cases where there are multiple open access copies of a file. So be careful with that because if you make a file list and just say, just give me all of the open access ones, you might add the same file twice as an example. So something to just keep an eye on and keep a lookout for as well. And yeah, if you find any nice tips or tricks, things that you stumble into that are needed or useful rather, let us know and we can incorporate them. This recording takes a little bit of time, but it will be on the YouTube channel as well within maybe a couple of days to a week. I will try and get it uploaded there as well. So I know people are kind of dipped in and out. They can come back and take a look at this as well. And yeah, that's it. So unless there's any questions briefly before we end, I'll stop there and we finish a tiny bit early, I guess. And thank you for the nice comments in the chat there, Sasha. I will, I guess, also if people are interested, probably after the sort of recording has gone live, I might post my sort of solutions to this as well. As I say, they're really just a case of, using certain tags, stuff like that. And certainly, as you're using this, I mean, I have to keep looking back to that list of tags and going, yeah, what's the tag again? Stuff like that as well. And the key thing, of course, though, is, once you get into some of these use cases, you're probably just going to be then trying to get the same list of files every time. Give me the latest files from my particular analysis or whatever. All right. I'll stop the recording there then. And thank you very much for joining and sticking it to the length if you've been here the whole time. Hopefully you found it useful and look out for more tutorials coming forward in the future.
Thanks a lot, Steven. So see ya.